Welcome to part 2 over our notes over covalent bonding. I am starting on page 4 in your notes, so you need to have not only your notes out, but a periodic table to assist you as well. Okay, so if you look about halfway down the page on page 4, we're starting at Lewis structures today. Lewis structures depict shared valence electrons in molecular compounds. So it actually helps us to understand how these bonds are formed, covalent bonds that is, how they're formed and where they're located, how many bonds there will be, and what this actual molecule is going to look like. Okay, so starting with the water molecule, for example, we know that hydrogen has 1 valence electron, and that oxygen has 6. So 1, 2, 3, 4, 5, 6. Now, by drawing the Lewis structure, I can see that the bond is shared, or formed rather, by sharing an electron from hydrogen and from oxygen. Okay? It says you can simplify a structural formula, or you can simplify by drawing a structural formula by just drawing lines instead of the bonds themselves. Okay, so that is a more simplified formula known as the structural formula. Our next example is carbon dioxide. We know that carbon has 4 valence electrons, and that oxygen has 6 each. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now, you may not have anticipated carbon dioxide looking like this. It has a double bond on each side of the carbon, and these extra valence electrons on oxygen. You may not have thought that would look like this. So in a few minutes, I'm going to show you how to figure out a formula that's going to help you draw these Lewis structures. Then we've got nitrogen that has 5 valence electrons each, which gives nitrogen a triple bond in the center. Okay? We know nitrogen is one of our diatomic elements, so there's 2 of them. Okay, creating Lewis structures. So here is the section where I'm going to teach you how to draw these structures. And there's an actual formula to it. So make sure to memorize these 6 formulas I'm going to give you, or 6 instructions. Number 1, draw a skeleton of the molecule. What I mean by skeleton is the arrangement of the atoms. It says it generally works to place the different atom in the center. Well, the different atom is oxygen, right? There's only 1 oxygen, but there's 2 hydrogens. So I have HOH. That is the skeleton. Okay, then we're going to find NAS, which are the next 3. Number 2 says, find the needed electrons for each atom and add them up. N will be 8 for most elements with these exceptions. So every element will have 8 needed electrons except for hydrogen, which needs 2, beryllium, which needs 4, and boron, which needs 6. So you need to have those 3 memorized. Okay, so water. It's made up of 2 hydrogens and an oxygen. Well, there are 2 of the hydrogens that each need 2 electrons, which is 4 electrons. Then you've got oxygen. There's 1 of them, and it needs 8, which gives me a total of 8. But I want to know the total number of electrons the entire molecule needs. So I have to add 4 plus 8, which gives me 12. So the N value for water is 12. 12 needed electrons. Step 3, find the available valence electrons, which is A, for each atom and add them up. Okay? The available electrons are the valence electrons. So there are, again, there's 2 hydrogens, and they each have 1 valence electron. Remember, I taught you that yesterday, how to get your valence electrons. Then you have oxygen. each one, which there's only one, has 6 valence electrons, which is a total of 6. But I want to know the total available valence electrons. So I have to add 2 plus 6 gives me 8 for the A value. So we said N was 12, A was 8. And a special note at the bottom, it says, when completing a Lewis structure with a polyatomic ion, you will do the opposite for the charge. Okay, this really long sentence is somewhat confusing, but you'll basically do the opposite of the charge. So, for example, phosphate, you will add 3 to A. But for ammonium, which is positive, you would subtract 1 from A. Okay, so you'll just do the opposite of the charge on the polyatomic ion. Okay, and I duplicated this on accident. So number 4 says you'll find the shared electrons for the entire molecule by this formula. So N, we said, was 12. A, we said, was 8. So N minus A gives us 4 shared electrons. Okay. The shared electrons are the bonding electrons. Place all of the shared electrons between the atoms. Okay, so between the atoms is in this region here. Okay, literally between them. Okay, not up here or down here or over here. Those are not in between the atoms. The red region is in between. Okay, so I'm going to place 4 electrons, 1, 2, 3, 4, in between. Remember, each electron pair, meaning 2 electrons, gives you 1 bond. Step 6 says you must place all of the available electrons in the pitcher. The shared electrons are part of the available. See how many of the available electrons still need to be placed and put them in the pitcher as lone pairs, unshared pairs, so that every atom gets an octet. Remember, hydrogen only needs 2. Okay, so we had our 4 here from the shared. I like to do an extra step, which is called the extra electron. And you get your extra electrons by taking A, which is your available, and subtracting S, which is the shared. So I had 8 available. I used 4 because they were shared. So I have 4 more electrons that have to go somewhere in this pitcher. Now, because only 2 can touch hydrogen, I know that 1, 2, 3, 4, that's where those extra electrons are located. Okay? Okay, so let's try this again. Okay? So more practice with Lewis structures. This time I'm going to do cyanic acid. Okay? So I'm going to get the NaS value. And this becomes quick once you know what you're doing. Okay? Remember, N is the number that they need. Okay? So we said hydrogen. Hydrogen, each one needs 2. Carbon needs 8. And then nitrogen needs 8 as well. So 2 plus 8 plus 8 is going to give me 18 needed electrons. Okay. A is the available or the valent electrons. Hydrogen has 1 valence. Carbon has 4. And nitrogen has 5, which gives me a grand total of 10 available electrons. And then lastly, the shared. Remember, shared is N minus A. So 18 minus 10 gives me my 8 shared electrons. And these are the actual electrons involved in bonding. Okay. So now I'm going to go ahead and I'm going to draw my skeleton, okay, which is going to be HCN, okay? Now remember, hydrogen can only have 2 electrons by it, so I'm going to use my shared electrons first. There's 8 of them, so I know only 2 can go here. So 6 minus 2, or 8 minus 2 rather, leaves me with 6, which means 6 electrons have to go in my last shared region between carbon and nitrogen. So I'm going to have a triple bond here, which may have been unexpected at first, right? So 1, 2, 3, 4, 5, 6. I've used all of my shared electrons. Now remember that extra one we did, which was to figure out the extra electrons? We have to use all of the available, remember? The extra is the available minus the shared. So the available is 10, I only used 8, I have 2 left over. Now those 2 cannot go on hydrogen, and they cannot go on carbon either, because carbon has 1, 2, 3, 4, 5, 6, 7, 8. But if I look at nitrogen, and I didn't mean to duplicate those here. If I look at nitrogen, it only has 1, 2, 3, 4, 5, 6 electrons touching it. So to fulfill the octet, it needs the 2 extra. Okay. So this is the diagram or the structure for cyanic acid. I want you to know where each electron goes. All right, let's try this again. The next example, NO3 minus. Okay, so we're going to draw this one. Okay, N is the number of electrons needed. Okay, and we said that they all need 8 except for 3 exceptions. Nitrogen and oxygen, none of those are exceptions. Okay, so for nitrogen, it needs 8, and for all 3 oxygens, they need 8 as well, which gives me a grand total of 32 electrons needed. A is the valence electron. Nitrogen has 5, and each of the 3 oxygen has 6. So this gives me a grand total of 18, 25. Hold on, I'm doing this backwards. Gives me a grand total of 23 valence electrons. Now remember, I said if there's a charge there, you have to do the opposite. So because there's a charge here, I have to add an extra electron. So I'm going to have 24 valence electrons. Okay? And that's because it's negatively charged, so I have to add an extra. And that was just that exception rule that was on the previous slide. And then your shared is A minus N minus A. So N minus A gives me 8 shared. Okay? And then I'll go ahead and do my extra right now. The extra was the available minus the shared. Okay? So 24 minus 18 gives me 16 extra electrons. Okay. So nitrogen's going to be in the center with oxygens around them. Remember, the rule was to put the unusual or least common one in the center. I'm going to start by using all of my shared electrons. That's where you always start, is in the shared section. Okay? And I have 8 shared. So I'm going to start by doing 1 bond in each. So 2 electrons, 1 bond. So 2, 4, 6. Well, I have to put 2 more in a shared region. So that means there's a double bond in one area and a single bond in the other 2. So I've used all my shared electrons. Now I have to go around and put those extra. Now remember, every atom only wants 8 valence electrons. So this oxygen right here already has 4. So that means I can only add 4 more. This oxygen has 2. So that means I can add 6 more. 1, 2, 3, 4, 5, 6. This oxygen has 2, so I can add 6 as well. And if I count for nitrogen, nitrogen has 1, 2, 3, 4, 5, 6, 7, 8. So nitrogen's happy. All right. So I used my 16 extra electrons. If you want to go back and check, you can. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. And those 16 extra electrons, their purpose was to fulfill the octet rule on all of the atoms. Okay? All right, so I want you to go ahead and to try the rest on your own in the rest of the class period. You do have homework where you're going to be trying to draw these structures. Okay? Now, on your homework, there are 2 columns on the worksheet. Tonight, just fill out the worksheet on the Lewis structures column. Don't fill out the structural formula, just the Lewis structures. Okay? And for closing, we've got resonance forms. And I'm going to finish with this. It says sometimes more than one correct Lewis structure can be drawn for a compound by changing the location of a double bond. For example, these are called resonance forms. Consider the possibilities for NO3-, which is what we just drew. Okay, so the way that I originally drew NO3- was with the double bond located here, meaning that I only had the 4 extra on this oxygen and the 6 extra on the other oxygen. Now, what I mean by something has resonance is that it can move this double bond. Okay? So the double bond can move into the other oxygen position. So for example, we can have the double bond located here. So now this oxygen will only have the 4 electrons on it. Okay? And the last position, as I'm sure you figured out by now, would be here. Okay, now why is it important to know what all of these look like? Because the actual compound itself is actually a combination of this. Okay, this bond is moving back and forth between all 3 positions, so it's important that you know where all 3 are. And the way to draw something that has resonance is to put arrows between them like that to show that the bond is going to move. Okay, and a lot of the time we'll also put these in brackets and put the minus outside of it to show that it's negatively charged. Okay, so go ahead and do that. Make sure to put them in brackets when they have a charge on them, like these polyatomics do, with the negative charge outside the bracket. And it says at the bottom, in reality, the extra pair or pairs of electrons are free to move into different bonding positions. The true picture of the molecule is one that is a blend or a hybrid of all resonance forms that you can draw. Okay, so I'm done with my presentation for today. You know what your homework assignment is. It's the Lewis Structures worksheet, just the Lewis Structures column and the calculations column, of course, with the NAS. You need that in order to actually draw the Lewis structure. Okay, so work on that for the rest of the class period, and I will be back tomorrow to help explain anything you don't understand. But this homework is due. I do want you to attempt it, even if you don't understand. Go home, rewatch the video, and get some sort of clarification. but I need you to try and to come tomorrow with completed homework. Okay? Have a great rest of the day and be good for the substitute. I'm looking for a good report.